Good morning to all. I am Dr. Dhondiba, Assistant Professor of Chemistry, Government First Grade College, KR from Bangalore. Today I am going to discuss about sixth session of chemistry and second session of gaseous state, which belongs to first semester BSc affiliated to Bangalore North University. In this session, I have to discuss about mean free path, collision frequency, and collision number. Now, main objectives of these sessions are definition of mean free path, collision frequency, and collision number. Then expression of mean free path, collision frequency, and collision number. And also that is SI unit of mean free path, collision frequency, and collision number. These we have to discuss in this session one by one. Now, after completion of this session, you will come to know about mean free path, definition of mean free path, collision frequency, and collision number. You are also able to write the expressions of mean free path, collision frequency, and collision number. And also you have to know about SI units of mean free path, collision frequency, and collision number. Now, before going to discuss this session, you have already known about collision of gaseous molecules. What is mean by collision and how it is takes place in a gaseous molecules, that you have to already known. Again, you have already known about meaning of arithmetic mean. What is the arithmetic mean or definition of arithmetic mean or average mean? And that is a arithmetic average that can be known. Again, also you know about what is mean by frequency. These you have already known about in previous second year. Okay. Now this session starts with, that is a mean free path. Here, at a given temperature, a molecule travel in a straight line before collision with other molecule. The distance traveled by the molecule before collision is termed as free path. Here, simple, because the distance will be depends on, that is the temperature. The distance at a particular temperature, a molecule travels in a straight line before collision with other molecules, and there is no any other molecules in the particular distance. That distance is called as a free path. Therefore, we say that distance traveled by the molecule before collision, it is a very free path and there is no interruption, and this is the term as free path. The free path for a molecule varies from time to time, because when beginning with the first when a molecule is moving, it will be having a speed more, or velocity of that molecule will be a more or high. When it collide with other molecule, then velocity of earlier molecule will be a decreases, and velocity of the other molecule, second molecule, will be increases. Again further, that is second collision will be takes, the still there is a velocity decreases. Again third collision, in third collision again velocity will be decreases. Therefore, we say that the distance traveled by the molecule in particular collisions, no, the different collisions, the distance will be a changing or it will be a decreases. Therefore, we say that the free path of a molecule varies from time to time. The mean now the mean distance traveled by the molecule between two successive collisions is called mean free path. Therefore, because of it is varying time to time, therefore we have to take, that is a mean free path means we have to take, that is a average mean free path. Average mean free path, that can be defined as the mean distance traveled by the molecule between two successive collisions is called mean free path. It is represented by lambda. If the L1, L2, L3 dash dash Ln are the free path for a molecule of a gas, then its mean free path is given by lambda is equal to L1 plus L2 plus L3 plus dash dash plus ln divided by n whole divided by that is Z1. Here the n is nothing but number of molecules with which the molecule collide. The number of molecules with which the molecule collide. Then Z1 is nothing but total number of molecular collisions takes place. Therefore, we say that this is the expression lambda is equal to that is average mean free path divided by its collision number. Then it is called as a expression for mean free path. Therefore, we can also from this expression we can write lambda is equal to this is goes to that is a mean distance traveled by the molecule. Suppose particular that is second in per second, that is called as a mean distance traveled by the molecule per second divided by total number of collisions per cubic centimeter. That is, it can be further written as mean distance traveled by the molecule per second is nothing but it is the average velocity of that particular molecules. Therefore, C bar is written and number of collisions per cubic centimeter means it is a Z1. Therefore, this expression is called that is another expression for mean free path. Then coming to that is a SI unit of mean free path. Mean free path is measured in terms of meter because the distance is measured in meter in SI unit. Therefore, the mean free path is always expressed in terms as a distance. Therefore, distance is measured in terms of meter. Therefore, SI unit of mean free path is nothing but meter. If the the number of molecular collisions will be a less at a lower pressure because as the pressure increases the number of molecular collision will be increases and also density of the molecules will be high, then the number of molecular collisions will be more. Therefore, we say that the molecular collisions depends on the pressure and density. Okay, that is a reciprocal. Higher the molecular collision, lesser will be the pressure and lesser will be the density of the molecules. Therefore, we say that and this is the if lower pressure and lower density will be there, the longer will be a mean free path will be takes place. Therefore, longer the mean free path, lower will be the pressure and lower will be the density of the molecules. Therefore, the mean free path is also related with the viscosity of the gas, which is given by lambda is equal to eta square root of 3 by P into D. That is this here P and D are nothing but pressure of the gas and density of the gas, and eta is nothing but coefficient of viscosity. This is the another relationship between the mean free path with viscosity, pressure and density. Therefore, lambda is equal to eta square root of 3 by PD. Now coming to that is the collision number. Now what do you mean by collision number? Here the number of collisions, it is defined as the number of collisions experienced by a single gas molecule with other molecules per second and per cubic centimeter is called collision number. How do you define? The number of collisions experienced by a single gas molecule with other gas molecules per second per cubic centimeter is called collision number. It is denoted by Z1. That is, we can write that is a directly expression that Z1 is equal to square root of 2 pi into average velocity into collision diameter square into number of gas molecules. Therefore, here sigma is nothing but molecular diameter. Therefore, we can say that is a Z1 is equal to square root of 2 pi into C bar sigma square and n. These are the product. And then coming to this expression is called that is a collision number of this expression. Okay. Now come to that is the SI unit of collision number. We know that Z1 is equal to, we know that Z1 that is the collision number is equal to square root of pi into average velocity into sigma square into n. Here, suppose average velocity can be expressed in terms of meter per second. Sigma square means sigma is nothing but molecular diameter, no? Collision diameter actually. Therefore, we say that is a meter square, and n is expressed in terms of per meter cube. Therefore, we will after that is putting the values this in this equation. Therefore, collision number is equal to, we will get Z1 is equal to per second. Therefore, collision number is measured in terms of per second, or we say that is a SI unit of collision number is per second. This is the SI unit of collision number. Now coming to that is the collision frequency. What is mean by collision frequency? That can be defined as the number of molecular collisions taking place per second per unit volume or per cubic centimeter of a gas is known as collision frequency. Here, how do we define? The number of molecular collisions taking place per second per unit volume of a gas is known as collision frequency. For that, now let the gas contain n molecules per cubic centimeter. Okay. Then from kinetic consideration, kinetic theory of gas consideration, it has been established that the number of molecules n with each a single molecule will be collide per second is given by a relation. The Z1 is equal to, this is called as a collision number. According to collision number, Z1 is equal to square root of 2 pi into average velocity into collision diameter square into n. Now here C is nothing but average velocity of the gas and D is nothing but collision diameter. If the total number of collisions taking place per second is denoted by Z, we have written as, because the collision will be takes place between the two molecules but not isolated. Therefore, we say that the number of molecules should be a other. Therefore, the total number of molecules, molecular collisions takes place by Z is nothing but square root of 2 pi into average velocity into sigma square into n into n. Here n because of the collision number, collision will be takes with other molecule. Therefore, we say that is a multiplying by n. Therefore, this after simplification we will get that is a root 2 pi average velocity sigma square into n square. Since each collision involves two molecules, the number of molecular collisions per second per cubic centimeter of the gas will be a Z divided by 2. Z divided by 2. Therefore, the total number of collision is nothing but it is divided by 2. Means the between two, suppose two molecules collide, then collision will be a 1. Therefore, n molecules are there, the collisions. Therefore, n divided by 2 will be the total collision. Hence, we say that is the collision frequency is equal to square root of 2 pi into average velocity sigma square into n square divided by 2. After this is simplifying, this root 2 and this root 2 get cancelled. We will get that is a root 2. After simplification, the Z11 is nothing but collision frequency, and it will be get that is a pi average velocity into sigma square into n square divided by root 2. This expression is called that is the expression for collision frequency. Okay, now the collision frequency of the gas increases with increase in temperature, because as the temperature increases, the frequency of the collision, number of collisions takes place more, and therefore as the collision frequency increases with increase in temperature and molecular size and number of molecules per cc. Therefore, increase in the collision frequency depends on the temperature, molecular size and number of molecules per cc. It gives that is a collision frequency. Now coming to that is the SI unit of collision frequency. We know that Z11, that is the collision frequency, is equal to pi average velocity into sigma square into n square divided by root 2. You have to substitute the value. Pi is nothing but constant value. Average velocity is can be measured in meter per second, and sigma is that is sigma is measured in that is a meter, and therefore it became a meter square, and n is nothing but per cubic meter. Then after putting these values, we will get what is that here meter per second. This is the meter, means this is the meter cube meter, and therefore we will get that is a simply after that is putting here value, after we will get that is simply per second per meter cube. Therefore, this SI unit of collision frequency is nothing but it is measured in terms of per second per meter cube. And this is about that is a collision frequency. So far in this session we have studied about mean free path, collision number, collision frequency, their expressions and SI units of these that is a mean free path, collision number and collision frequency. Now therefore I will ask some questions, you have to answer the questions. Now first question goes to that is a average distance traveled by the gas molecule between two successive collisions is called, first one, A collision number, mean free path, collision frequency, and D is nothing but none of these. Choose correct the answer. I will give that is 10 seconds for you people. You have to that is observed and you have to give the answer. Now answer for this question is B is the correct answer, because the average distance traveled by the gas molecule between two successive collisions is called mean free path. Therefore B option is the right answer for this question. Then second question goes to number of molecular collisions taking place per second per unit volume of the gas is called A option mean free path, B option collision number, C option collision frequency, and D is nothing but none of these. I will give 10 seconds for you people. You have to choose the correct answer. Answer for this question is that is C option collision frequency. Therefore, collision frequency can be defined as number of molecular collisions taking place per second per unit volume of the gas is called collision frequency. Therefore, C is the right option of this question. Third one, the number of collisions. Third question is the number of collisions experienced by a single gas molecule with other gas molecules per second per cubic centimeter is called, one is collision number, B is mean free path, C is nothing but collision frequency, and D is nothing but none of these. Choose the correct answer. I will give 10 seconds for you people. The right option of this question is A option, that is a collision number. The collision number can be defined as the number of collisions experienced by a single gas molecule with other gas molecule per second per cubic centimeter volume is called collision number. And these I have made references for preparation of this session, and this complete this session. Thank you.